In this video tutorial, we're going to discuss lateral seismic loading options in ADAPTBuilder using the Seismic Load Wizard and also using the generic lateral load input wizard. This will illustrate these options in detail and will show an example of applying the seismic loading to a structure and obtaining a lateral static solution relative to the loading and available reports. We're going to go ahead and launch ADAPTBuilder, and in the splash screen we're going to select the option for Adapt Edge. This is our multi-story solver and frame analyzer, and also Floor Pro would allow us then to evaluate individual floors and design horizontal slab strips. We're going to be working in RC mode without post-tensioning and in US units today. First thing we're going to do is actually build a model. So I'm going to go over to Model and I'm going to define some stories. I'm going to import a CAD file to build the model from, and we'll go ahead and just add several floors here. We can rename the floors to be consistent, so we'll call this plane 3, plane 2, and then we'll call this just base. Okay, and we're using 10-foot story heights. I'll change a couple of these. We're going to create a couple of larger story heights or taller story heights. We'll say 15 on the bottom 3 floors. And we'll change this to 12 for 3 floors. Okay. And we're working in single level mode. So when we import the CAD file, we're going to actually build the model at this level, and then we're going to copy the model vertically. We'll go ahead and we're going to file import. We also have options for importing from Revit and also ETABS if you have a multi-story structure built in either of those softwares. You can import those here into ADAPT. We'll select the option for DWG, and we'll navigate over to the file that we're going to be working with. We're going to calibrate the file. The other two options, if we're going to import additional CAD files, you may want to move it into a XY origin, so that would be important in that case. We'll just calibrate it to scale it into this interface, and I'm going to call this level 2. And now we have our structural level that we're going to work with. Now we need to calibrate. The program is prompting us to calibrate using a start point. So I'll go ahead and use my snap tools down here on the docked user toolbar. We'll go ahead and select the snap to endpoint, and we'll go from A to B, which is 20 feet, the grid spacing there. And we'll select OK, and that calibrates the file. The next thing we're going to do is we're going to transform components into polygons. So I'll select polygons. The slab, for example, is a polygon. This slab is also a polygon, so we'll select this slab and this slab. We have 2 slab regions. We're going to go over to Model. On the far right end, we have the Transform panel, and I'll transform these into slabs. I'll now transform openings in a similar manner. We'll use the openings option, and we'll just work through the model transforming these different components. Okay, now if I wanted to window sweep the different columns that we're looking at here, we can isolate that layer. We'll go over to Home, Layer Settings. It's also down on the bottom user docked panel there, and we're going to turn all layers off, and I'm going to just navigate and turn that one layer on. Now if I want to know what layer it is, let's go ahead and cancel just for a moment. We could double click on the polygon, open the properties. This is called Tutorial Level 1 Column. So now we can isolate that one layer. We'll turn everything off again. I'll sort this by alphabetical order there, and we're going to select this. Okay, these are the columns. I'll window sweep those, and under Model again we can transform to columns. I want to show everything again, so we'll come back to Layers, turn all layers on, and now I'm going to go ahead and select my walls for the model, and we'll transform those single walls into structural walls. Okay, so we'll go over here to model again. Those are transformed to walls, and the last thing I have are polygons representing my beams, and we'll transform those to beams. So now we're left with a structural model. I'll turn my CAD file off. I may not want all of those lines. If we want a separate grid file, we would have to import that separately. This particular grid file can be left on only through filtering layer. So you could technically leave this layer on, turn everything off, leave this grid layer on using the grid lines layer. We'll turn everything off again, and then I'll just reset my structural view from visibility. We'll go back to the default display. If I go to a side view, we have this set of components at level 2. I'm actually going to go ahead and copy this vertically. We're going to model, to modify vertical, and I'm going to copy this up 12 times. Okay, if I go over here to global mode, you can see that's been copied up to the last floor, which is plane 12. And this is the model that we'll be working with. So we'll go ahead and save this. Okay, and we're going to go ahead and select the slabs. So we'll use select home by type just to filter select the slab regions. And I'll just add some gravity loading onto the structure. We'll map the load to the selected slabs, and we'll add 15 PSF superimposed dead load, and for live load I'll add 50 PSF. Okay, so we have some gravity load onto the structure. Now it's important to know how the program classifies the loads. If we go over to the load case library, we can see that we have basically two categories: general loads, which are basically gravity loads, and any lateral loads that are input onto the structure manually that would represent a reaction. This would be kind of a classical case in the program, would be for use of a podium slab. If you have a podium that you have several reactions from lateral that's going on above the podium, those will be represented as a general load. For a global set of loads, for example, a wind pressure profile or seismic loads that are vertically distributed into the slabs, those would be classified as building loads. The user can manually enter a building load, or we can define building loads using the wizards. Now, the first thing we're going to show is what do we do when we manually enter a building load. We'll go ahead and let me turn off the loading here. I'll go back to my default display, and we're going to call the first load EQX. I'll do _M for manual, and I'll just add that. And maybe we do also one called EQY _manual. And these are both seismic. They're tagged as seismic. We'll change that. And now I need to build loads that are applied to those two load cases. So for example, if I know the center of mass, or I know the story force that needs to be applied to these levels, I would have to go to each level and apply a load. So for example, maybe I'll go up to level 12 in single level mode. I'm going to go into a plan view, and I'm just going to apply a load. And we're just going to say I want to apply a load here. This could be a uniform lateral load, it could be a point load, it could be line loads, it could be multiple loads, but we're manually adding loads. So this load that I'm going to add is going to be defined as EQXM, and we're going to go to loads, and I'm going to say that this is a 100 kip load in the positive X direction. Okay, any torsion would just be inherent due to the placement of the load versus the natural center of rigidity of the structure. So here you can see I just arbitrarily selected it. The user would need to know where the center of mass is relative to this floor and apply it at the specified or required location. So this is an example of a load that's manually applied. I could do the same for the Y direction. Before I place this, I can go to modify it, item properties, go into the properties. I'm going to change this to Y, And I'll change this from 0, let's say, to 100 in the positive global Y direction. And we now have that load. Okay, and I'm going to go now to loading combinations, and I'll create 2 additional combinations. We have some default gravity combos here, but we're going to change this to no code check. And I'm going to call this, it cannot be the same name as the load case, so we'll call this Seismic X and Seismic Y. And we'll go ahead and apply a factor of 1 EQX, 1 EQY. Now, if I try to run this particular level in single level mode with applied building loads at this level, if I go ahead and mesh this particular level, this really is not a let's say an accurate representation of a set of global story forces that would be applied to mimic a seismic event. This is just 2 forces that are now being applied to a single level in isolation. So in this case, because these are classified as building loads, if I go to analyze, you'll notice that those 2 combinations that I added are not listed. The program filters them out. If I switch back to multi-story mode, and I'll go ahead and I'll remesh this. I'm going to remesh. Once I'm in multi-story and I mesh, it's going to mesh the entire structure. Okay, and now we have a full structure mesh. We'll save this. Under execute analysis, now those 2 combinations are listed. Because we're in multi-story mode, they're building loads, and therefore they're solved for only in multi-story mode. If I actually take these 2 combinations and run the analysis, we can get a response. The loading here is purely lateral static method. There's no currently no dynamic analysis or response spectrum modal analysis in ADAPTBuilder at this time. So everything is done on a lateral static basis. Okay, that provides a solution. And just to take a cursory review of the deformation, let's say, for this model, we'll go into the view analysis results option. And if I go ahead and select the combination, we have seismic X. Maybe we want to look at the X deformation. We'll just do a 3D deformed view of this model. And we can see the overall structural displacements in the positive X direction. And the same thing can be done for Y. We'll switch this to Y. And once we switch that to Y, I'll go now to the Y direction, or we could do a resultant, we could do global, for example. But these are the displacements now for the structure. Now, it's also important to note, by default, the program doesn't release moment fixity of columns to slabs. The user would need to go in and adjust that. In addition, if the user wants to modify the stiffness of components, we can use usage cases to do that. And we'll show that here in a moment on how to apply a usage case. So that's how manually applied building loads would be handled in the software. Now we're going to go back and we'll go back to loading, and we're going to get rid of those 2 cases. And I'll actually delete out these 2 load cases here. Okay. The next option is the seismic load wizard. If the user wants to rely on this wizard to produce the story forces, we can open the wizard. The user would just define and create a load case name. So we'll call this EQX. This is applied in the positive X direction, which aligns here. This 0 degree is positive X, 90 degree is positive Y. So if you want to apply eccentricity or torsion, we would create, for example, EQX. I'm going to actually call this positive T, and this 5% is acting, let's say, clockwise. Okay, we'll fill in the different spectral acceleration values and the different values that define the characteristic seismic parameters, let's say, for ASC 7. The user also has the option to user define this. You could user define a seismic response coefficient, a base shear, which the program would then use and just distribute the loads vertically. or you could also input each story force directly here in this table. So there's a few different options for use here. We'll go back to the input here. I'm going to create a different value there for the S1 value. We'll say it's 1.2. The R factor we're going to say is 5. And then there's different options for creating and calculating the period for the structure. So we can do by equation or user defined. Technically, the user could run a vibration analysis in the program and generate the period for the program and the frequency for different modes of vibration. That's handled under the analysis ribbon. So we'll just use by equation. Okay, the seismic mass is defined by this combination. It can be edited here. And now I'm going to just apply that. Once I apply it, it basically just stores that data until the program analyzes the structure. So we're going to now create a negative t. This will just be -5. Okay, and the next thing we'll do is create what's going to be called EQX. We'll say it's positive t again, but we're also going to do negative direction. Okay, so this is actually going to be in the not in the 0 degree direction. It's going to be in the 180 degree direction. You could also plus minus inside of the load combinations. That's another way to handle this. So we'll change this back to 5 and I'll apply that. We'll then go back and change this to negative. So decide what your own notation is here. This is just shorthand notation for what we're trying to describe in terms of the loading. And we'll call this -5. And we would then do the same for the y direction. Okay, so we would, we could create it really for any direction in terms of degrees. So positive y again is 90, negative y is 270. If you want to create loading conditions on the diagonals, we could use 45, 135, etc. Okay. So now we have 4 stored sets of load cases for seismic. The program uses these cases to generate story forces. Those are only calculated once we actually solve the system. The program distributes the story force at a nodal level, nodal forces, nodal moments based on the torsion, and those are all tabulated and solved for at the onset of analysis. We'll go ahead and close this. I'm going to go back to my load combinations, and I'm just going to add additional combinations here that define the seismic. So we're going to call this seismic. I'll just say it's seismic 1. This might be seismic 2. You may want something more descriptive here in a real model, but this doesn't really tell us much about the applied force or the direction. And seismic 4. Now, these load cases that we created will have to be combined with other gravity load cases to evaluate different combinations, both for service level and strength level, based on whatever code you're using. These are just some check, let's say check combinations we're going to create here. We'll set this to no code check. I'll set actually one to service, because once it's tagged as service, you can actually check the drift for the columns, and also drift at a few other locations. That's upcoming in version 2019. We're going to have more drift reporting for that particular version. So using this set of labels, we'll go back now and we'll say, okay, the seismic 1 is going to be 1 times EQ positive T, 1 times EQ negative T, and then we have the opposite direction positive T, the opposite direction negative T. Some of these actually may produce very similar responses in the structure, but decide how you want to use the input and build out the different load cases. So we'll go ahead and select OK, and now we can rerun this. Again, if I'm in single level mode and the combination only includes a building load, it won't be shown. If I come back to analysis, execute, those 4 combinations are not shown. Once I go into global mode, they are shown and we can run them. Now, you'll notice right here it says apply stiffness modifiers uncracked. This is called a usage case. Uncracked usage means that nothing is cracked. Everything is set to 1. The modifier has to be 1 or less. So if I double click on any component, I'll just click this column for example, and I look at the stiffness modifiers. There's my uncracked usage case. It's read only. I can't modify it, but I can add additional usage cases. So we'll edit a usage case. I'll add one, and I'll call this just stiffness 50%. We're just going to say everything has 50% stiffness. Technically, that's not what the code recommends, but we'll make it easy on ourselves here for the example and use 50%. I clearly don't want to change these one by one. That's just inefficient. It will take too much time. So what I'll do is I'll just select everything. I'm going to go to modify the selection. Once I get into here, this filters what's going to be changed. So under column, we can go to stiffness, and here I can modify the stiffness and assign my factors to these different values. We'll just select and set 0.5 to all of the bending rotational stiffness values there. That's for columns. So I just set all of my columns. If I just spot check one, you can see this sets that to 0.5. I'll come back and do the same for, go back to modify selection, do the same for walls. We could also modify the axial stiffness of the wall vertically or also in plane stiffness. We'll just do the bending stiffness modifiers. And we could do the same for slabs. We'll leave the slabs at 0.5, or excuse me, we'll set the slabs to 0.35. So we'll come back, select everything. Again, repeat the procedure. We'll go back to slabs. Here we're going to set this bending stiffness to 0.35. We'll add a little bit of variety there, even though we said earlier we would not. So we'll add that as 0.35. And now we're going to run the model. Now when I analyze, you'll notice I now have the option to set this to either uncracked or stiffness 50. So the user gets the option to decide which usage case you want to use. You could have 10, 20 usage cases here if you want, and run each one separately. So one of them has to be set. You can't run the program using different usage cases. We'll select stiffness 50. And one more thing before we actually run that, I actually want to pin my columns. So right now, again, if I double click on a column under release, you can see there's no rotational release for the column. I'll just select by type again my columns. And under modify selection, we're going to go back to column, and we're going to release the top and bottom rotation using these checkboxes. Okay, now we're ready to run this, and we'll run it for those 4 combinations. Okay, and we get a solution for these lateral cases. Now again, we could go back to our viewer just to make a quick review of the deformed shape of these different cases. Maybe we want to look at seismic 1, for example. We'll look at the global displacement here. And this might help verify some of the intuitive behavior that the user might expect, given the loading condition or case. If we come out of this, I'm going to go to wall design and just isolate the walls. We could also, once we run the analysis, I could select the combination. You'll notice I have 3 no code checks and 1 service, so we'll go to service 1. This is in the primary X direction. We do have some torsion, but if we go to wall design or the wall category under the analysis tab, and we look at the actions, we can look at the shear forces, in the walls. Bending about S, this is strong axis bending. So we have different design values that we could look at and pull those out either graphically or through reports under the reporting options here for wall reporting. For columns, if we wanted to see what the drift was, for example, The drift can be reported both for walls and also for columns. If we come here to drift, this will give us an indication whether the inner story drift meets or exceeds the maximum allowable, which here is set to 0.5%. This does not include any consideration of an amplification factor for drift based on the code for seismic loading. So the user would have to embed that into the allowable that they produce. And that allowable can be set under display. We have the option here under drift maximum allowable. Okay, so that's where you can code check drift. And the same can be done for columns. If I come back and do columns only, I can switch that and we'll expand columns and look at the drift there also. Okay, so that's just a quick review of just a few of the results you can get using these lateral combinations. For determining the center of mass and also the story forces that the program actually calculated, we can go to Reports. Under Reports, we're going to go to the Loads option and Applied Loads. And the Applied Loads report is going to actually show us and tabulate the base shear, all of the different seismic coefficients and parameters that we entered, and also the story forces that are calculated. So this gives a reporting of that. If I just go down to the end of this report, we have several gravity loads, and then we get into the EQX positive T, for example. This gives us center of mass, eccentricity based on the 5% input that we made, story force, and story torsion. And this is shown here. You can see we have the seismic base shear, total seismic weight or mass, and this itemizes those values for each seismic combination. You can also check this graphically. If we come back to the slab view, and I'll go and isolate this again into single level mode and top view, we can come back and under reports, I can view loads. We're going to do graphical user defined loads. So if I do EQX positive T, this is going to show the center of mass location, force, and the moment based on the input. So you can actually navigate down the structure and produce that report graphically. Now the third way of applying loads to a structure for seismic would be to use the lateral load wizard. This looks a lot like the seismic load wizard. If we were to actually change this over to user defined and go to story force, we can enter forces directly. And under the lateral load wizard, same thing happens. Here, this is just a condensed version of that seismic load wizard without input of the parameters and coefficients. We define whether it's a wind load or a seismic load. Here, we distribute the forces, again, nodally, both the forces and the moments, but the user would input the combination, the story forces, eccentricity, and direction. And the program treats these types of loads identical to how we handle the seismic loads produced from the wizard. So if you have any questions about these inputs, please contact us at support@adaptsoft.com.